All right, we're in.
Wait, I'm chewing.
Can somebody close the door for me, please? That'd be so nice.
Welcome to another class of solving inequalities with the cardios.
Here we go. Guys, I need about 20 minutes in terms of time to get through this lesson, and then you'll have about 20 minutes to do your follow-up. I changed my mood. No, I want to sound good.
Well, that's
No, I'm getting sick. Inequality, here we go. A comparison. Lesson 1-4.
Wow, we're flying through this packet. Yeah, it's 15.
We find it?
Did you teach algebra too?
Hmm?
I wish I had
All of them, he's been over this already. You have him now.
Yep.
back for algebra 2 because I missed my content.
I have her study.
It was just bad.
She's gonna listen to this.
All right, here we go. Inequality is a comparison of numbers and or variables. A comparison of numbers and or variables. 4 symbols that we're going to use. You guys know these symbols. It's this. It's this. That or that. Oops. So we have greater than. And then less than or equal. Guys, we can write inequalities one of 2 ways. We can put, actually, I don't want to say one of 2 ways, but we can write this inequality one of 2 ways. In this case, the 3 is prior to the x. If I wanted to write the x first and swap those 2 around, I also need to change the inequality to face the other direction. So I'm allowed to do that as long as I change the inequality to face the other way, right?
Right.
Right.
Can you read?
So here's an easy way to think about it. We don't necessarily like to have the number prior to the variable when we read it.
Oh, okay.
We typically like the variable first, right? So if we want to think about it in terms of which way is this opening up? Here it's opening up towards the x. So if I rewrite it, it still needs to open up towards the x. That's a good way to think about it. Is the given solution, actually I didn't read that right. Is the given number a solution? Okay, is the given number a solution? So in other words, is 5 a solution to this? I agree. I don't think it is. What am I going to do? I'm going to take 5 and plug it in, right? So is 5 plus 3 less than 6? Right. All right, now we're going to take the 1. And, oops, wrong number. This is the kind of comparison, guys, that people might have some trouble with, right? And the way that I always explain it to people, right? In which scenario, again, I always think money, guys. In which scenario do you have more? When somebody owes you $1 or when somebody owes you 3, right? Which of those, in which case do you have more money in your pocket? When somebody owes you $1 or when somebody owes you 3? Owes you $1, right? So this number is greater than this. Guys, the other way you can think about it is there's 0 on the number line, right? So here's -1 and here's -3. So do you agree that things further right are bigger than things further left, right? So -1 is a bigger number than -3, right? So lots of ways to think about it. With this, now I have to plug it into two different spots, right?
The number after like.
Is the number we're testing. Yep. Yep. Oh, +2, sorry. Sorry, +2. 11, all right? True or false? So this is true. All right, and this one was false, okay? Oh, yes or no, sure. So no or false. Are you good? All right. You said this one was true, you're right. This one was true. You're right, that one was true, this one was true, this one was false. Good. Any issues? Happy? All right. Graphing inequalities. So here's the deal. When we graph these, we put them on a number line, okay? And here's what I want you guys to remember. When we do these, we're going to follow 3 steps. First thing we're going to do is we're going to draw a number line. Now, I want you to always, always, always do this. What is furthest left on a number line? Keep going. Negative infinity. Furthest right? Positive infinity. I always put these on my number line because when I write the arrows, that's what I'm insinuating, right? Yeah. Now I want to plot all important coordinates. So in this case, the only thing that I'm really interested in is the number, which is 2. Then what I have to do is choose an open circle or a closed circle. Now here's what this means. An open circle is going to be this or this. A closed circle is going to be this or this. Here's what it means. Closed means equal to. Open means not equal to. Okay? So let me sort of put all this together into one problem. We did our number line, we did our important value. I want to be less than 2. Does this insinuate that I can equal to? No. So that means I need to be less than, which means an open circle. So I'm going to put an open circle on 2. Right? And then the last thing I need to do, and I'm going to add this to our list here, guys, choose an open circle, and then step 4 is going to be to shade if necessary. What do I mean by shade? Well, are there answers that can fit within this inequality? Is there a number that's less than 2? Give me it. Okay. So I'm going to put 1 here. You guys all agree that 1 is definitely less than 2. So I'm going to shade this direction. Yes. Yep. So what I did here, guys, to determine which way is I took a test value. In this case, I did a test value of x equals 1. I'm showing you right now. Okay. So I did a test value. In this case, I chose 1. So I know that this is my problem. Is 1 less than 2? Yes. So Zimmer, what that means is I have my open circle on 2, right? My 1 is here, so I want to draw a line where the 1 is, indicating, Zimmer, what? That 1 is a solution, 0 is a solution, -1 is a solution, and everything that way. That's right. Okay? Let's do the next example and then follow up if you have any questions, okay? Here I want to graph x is greater than or equal to 3. No, I'm saying this is what I want to do. So I drew my number line. Go ahead.
Do I have to draw the zeros?
In the infinities.
Like, yes.
I like them there.
Same for me.
Yes.
Okay. No, that's
Yep.
right.
You'll see why in a couple days why I want you to do that, okay? Now what goes on this? What's the only important value? All right, so I put 3. Am I allowed to be 3? Yeah, because it said what? Greater than or, which means my circle is closed or shaded in, right? All right, now what value do you want to test? Good. So we'll test 7. We'll test x equals, sure, 19. So is 19 greater than or equal to 3? Yes. So I'm going to shade where 19 is, which is over here. Thank God. I wanted to know. I was just really appreciative. I didn't even have to ask. Good? The circle? I don't know. I'm sure. No. I mean, it's just an error. Then fill it in. Yes. From now on, it better be filled in. If it doesn't, you're going to lose all your points. All right. Now, here's the deal, guys. If we can graph a simple inequality like the ones we did, then we're going to be able to graph one that's a little bit more complex. Now, guys, it's not complex because what we're actually going to do is take what we did the last couple lessons, combine it with today, and we're on our way. So solving an inequality is just like solving an equation. So in other words, whatever you do to one side, you must do to the other, right? So I'm going to pretend, Logan, like the inequality sign is an equal sign, okay? And you guys know I like to draw that line. Got to get x by itself, so all I need to do is subtract 4. And so I get x is greater than 3. Then it graphs, right? Then we got to graph it. So we have our number line. We have our key value that we're interested in, which in this case is 3. We want to be greater than 3, so do I want it open or closed? Open circle. All right. Michaela wants to test 8, so we're going to test. Is 8 greater than 3? Well, you might figure out later on why we're testing it. There's again, everything I'm doing here, guys, is to get us ready. Yeah. So now here's the nice thing about it, guys. We have our number line, right? Where is 6? Well, 6 is here. Is 6 in the shaded area? Yes. Negative 14 is over here. Is negative 14 in the shaded area? Okay. What do you guys want to do first?
Get rid of the x's.
Get rid of the x's? Okay, tell me what to do.
Subtract
Subtract
the 2.
the 2x. Because again, I'm pretending like this is a regular equation. All right, now what? Add the 1. Somebody owes you $3, they pay you $1 back. They still owe you 2. All right. And Zimmer, to me, this is why I do the test value. As soon as I throw negatives in there, it messes some people up. He's being facetious. -2, what do you guys want to do? Open or closed? Okay. Now, I'm going to give you guys a word of advice, okay? I know that we tend to want to use these other numbers for test values, 19 or 8 or whatever. To me, the test value I always use, unless it's the key point, is 0. Here's why. A negative number is here, right? So where does 0 have to be? To the left of it or to the right of it? It's got to be to the right of it. So to me, that's really easy to figure out. So now when I test this point, is 0 a smaller number than -2? Well, if 0 was a smaller number than -2, where would it be? It'd be over here, right? Okay, so is 0 less than or equal to -2? The answer was no, so I'm not going to shade where 0 is. I'm going to shade the other direction. That was my test point. 0 was my test point. I like using 0 because it's easy to figure out where it goes. You know what I mean? Okay, so I want to make sure that this is clear because this is the first time it happened. My test point, which was 0, did not work. Since it did not work, I don't shade where it is, I shade the other direction. Okay? Everybody's all right with that? All right. I got 2 more, and something important's going to happen in the last one. Something important's going to happen here as well. Guys, what am I doing to my y? What's this 3 doing to it? It's multiplying. What's this 5 doing to it? Careful. Dividing, right? It's on the bottom of the fraction. So what's the opposite of multiplying by 3? Dividing by 3. And what's the opposite of multiplying by, or I'm sorry, what's the opposite of dividing by 5? Multiplying by 5. So you flip it. And you guys have heard this phrase used. And the phrase is, when you want to get rid of a fraction, you multiply by the reciprocal, right? And that's exactly what we did. So the fraction is gone. So y is less than or equal to? It's just less than? Thank you. So y is just less than. This is going to be -5. Now here's the reason why, guys. Okay, do we all agree that this -3 is over 1? So what happens to this 3 and this 3? They cancel out, so you're left with the -5. Okay? So on our number line, there's my -5. Where's my 0? To the right or the left? To the right. Is 0 less than -5? No. No. So which way am I going to shade? I'm going to shade the other direction. All right, here is the one thing. Does everybody agree that up until this very moment, we basically took everything that we've learned with solving equations and then applied it to this with the shading on the number line? Okay. There is only one instance where the game changes, okay? And it's this. When you multiply or divide by a negative number, you need to flip the inequality. Yep. Okay? When you multiply or divide by a negative number, you have to flip the inequality. So here's the deal. Emma, the only time that that's ever going to happen is in that last step. Like with this one here, I had to multiply by 5/3. With this one right here, I didn't do any multiplying or dividing. With this one right here, I didn't do any multiplying or dividing. But if I gave you this problem right here, in order to get x alone, I would have to divide by -4, right? So that's dividing by a negative number, okay? So how do I get rid of the 4? How do I get rid of the negative 4? I divide by negative 4, which means x, now I have to, yes. So x is greater than or equal to a negative. What's 4/5 divided by 4? All right, I'm going to show you guys a quick trick. I have 4/5 over negative 4, right? Guys, make negative 4 a fraction really quickly. Negative 4 over 1. And then keep, change, flip. So keep the top fraction. Change division to multiplication. And flip this. So what happens? These 4s can't, careful. No. Where's the 5? So it's negative. It's negative 1/5, not 5. 5's on the bottom. So these cancel, and you have negative 1/5. Okay. Graphing on a number line? Yep. What? There's 0. There's my key point. Shaded in because it's equal to. I already put it there. So is 0 greater than or equal to negative 1/5? Yes, because it's to the right of it. Okay. Guys, this is sort of an odd way that I wrote this. Okay, I'm going to show you the circumstance where I'm going to save you some time. Okay, don't write this down. Just watch for a minute, please. Yes, I am. Okay. Do we all agree that this is an inequality involving some linear equation, or a linear inequality, right? Lines. Do we all agree that I've told you to solve this like an equation? Now, if you remember a couple of days ago, the thing that I suggested to you guys was when you move your x's, move the smaller of the two. So if I have 2x and 4x, I suggested that you move the smaller, which is the 2x. The reason why? So you don't get a negative. Right? Add the 9. We get that, right? And then we divide by 2, and we get 4 is greater than or equal to x. What's the other way I could write that? Exactly. So that's one way, Logan, right? That's one way. Now, if somebody had chosen to go the other direction, like this, here's my line, add the 1, I would be there, right? But what am I going to do in my next step? Divide by negative 2. And when I divide by that negative, that means that I need to flip the inequality the other way, and we get the same answer, don't we? It tickles the brain, sure. But the thing, guys, again, is in this scenario, I run into the risk of having that rule happen and maybe forgetting about it. So if you keep it in your mind to always move the smaller thing, then you don't have to really worry about that, do you? Okay? I'm done.